Hello everyone. In this video, we are going to learn about mathematical analysis of non-recursive algorithm. Non-recursive means consider as a forward substitution for just now. Okay. Next, general plan for analyzing time efficiency of non-recursive algorithm. It is a question asked. Write a general plan for analyzing time efficiency of non-recursive algorithm. It consists of 5 steps. In the initial step, we have to decide on parameter indicating an input size. Next, in the second step, identify the algorithm's basic operations. In the third step, check whether number of time basic operation is executed depend only on input size of the input. If this basic operation is depend only the input size, then if it is also depend on some additional property, we need to check worst case, best case and average case efficiency. If it is depend only the input size n, then we no need to find the worst case, best case and average case. Okay. Next, the fourth step, set up a sum expressing number of times the algorithm's basic operation is executed. Determine a sum for the basic operation is executed. In the fifth step, using standard formulas and rule of sum manipulation, either find a closed form formula for count or at least establish its order of growth. In the fifth step, we need to find the order of growth using a standard formulas. Let's see this general plan for analyzing time efficiency of non-recursive algorithm by some examples. The first numericals on non-recursive algorithm is finding the largest or maximum element in a given array. Let's see the algorithm. Algorithm maximum value array of 0 to n minus 1. In this algorithm, we determine the value of the largest element in a given array. Determine the largest element in a given array. Input is an array A. We consider give a name array as A, 0 to n minus 1 of real numbers. Output is the value of largest element in A. That is, consider an array, name given to the array is A. Next, input is 0 to n minus 1. Why n minus 1 means we start index at 0 and this array consists of 5 element, and we check this whole array, that is till this index, that is last index n minus 1 position. Always the last element is present in n minus 1 position. Hence input is an array A 0 to n minus 1 of real numbers. Output is what? The value of largest element in array. We have to get the largest element in this array. We can clearly see 9 is the largest element in this array. We have to find an algorithm to check which is the largest element in the array. Algorithm is maximum value array of 0. For I 1 to n minus 1, do if array of I greater than maximum value, then maximum value equal to array of I. Return maximum value. Let's check this algorithm by this example. Consider we have array of 5 element and the last position is n minus 1, that is 4. Maximum value is A of 0, that is in initial condition we set the maximum value as A of 0. A of 0 consists the value 2. We consider 2 as a maximum value. Next, for I 1 to n minus 1, that is I start from 1 to 4. For I 1 to 2, 3, 4, we have to find if values. If condition we have to check and determine what is the maximum value. In the first condition, A of 1, A of I greater than maximum value, if this condition is true, then assign the maximum value as array of I. That is, if array of 1 greater than maximum value. What It is array of 1 means that is array of 1 is 5. Whether it is greater than maximum value, in the initial condition we assigned the maximum value as 2. Whether it is true? Yes. If it is true, then we assign maximum value as array of I. Maximum value is array of I, that is 5. In the next, I is incremented, that is array of 2. Again we check the condition whether it is greater than the maximum value. Array of 2 is what? 8. 8. Whether it is greater than the previous maximum value 5? Yes, it is true. Then we assign the maximum value as array of 2, that is 8. Next we have to increment I, that is I become 3, array of 3. Again check the condition whether it is greater than maximum value. A of 3 is 9. Whether it is greater than the previous maximum value. 8. Yes, true. Assign the maximum value as array of 3. Next, in the fourth, I is again incremented by 1. A of 4, whether it is greater than maximum value. Array of 4 contain 3. Whether it is greater than the previous maximum value. No, it is false. Then it return the maximum value. We assign the maximum value is 9. Okay. In this we find the algorithm with the example. Okay. In the next we have to find the mathematical analysis of this algorithm. Okay. In the first step we have to find what is input size. Input size is nothing but we taken the array of n element, that is number of element is n. In the next step operation, we perform two operations, right? Comparison and assignment. But basic operation is what? Which is operated in every for loop, every loop statement, that is comparison. If comparison is true, then only we assign the value, right? Hence basic operation is comparison, which is we are doing in every loop. And in the third step we have to find basic operation is directly depend on the input size, or it depends on some additional properties. In this basic operation depend only the input size n, hence we need to check the best case, worst case or average case. Okay. In the fourth step, let C of n denotes the number of comparison. Algorithm makes comparison on each execution of loop, which is repeated for each value of loop's variable I within the bound between 1 to n minus 1. That is nothing but C of n from 1 to n minus 1 we checked the comparison condition, right? That is 0 to 4 we checked, that is I equal to 1 to n minus 1, 1. Next, in the fifth step, we have to simplify the summation using standard formula. C of n equal to summation of I equal to 1 to n minus 1, 1. Summation I 1 to n minus 1, 1 is upper limit minus lower limit plus 1, which is the general formula you should have to remember. In this, what is upper bound? That is n minus 1 minus lower bound plus 1, that is n minus 1. Hence we can say C of n is belongs to theta of n, which we have to find the order of growth. Hence for this formula order of growth is theta of n. The second example is to find the element uniqueness problem, that is we have to find whether the array consists a distinct element or same element. Okay. Algorithm unique element array of 0 to n minus 1 determine whether all the elements in a given array are different or distinct, or whether the elements are same. Input is again an array of 0 to n minus 1. Output is return true if all the element in array is distinct, and return false otherwise. Let's check the formula. For I equal to 0 to n minus 2, do. For j equal to I plus 1 to n minus 1, do. If array of I equal to array of j, return false, return true. Okay. Let's see this algorithm by an example first. Consider a given array, again consisting of 5 elements array. and we have to take two loops for comparisons. Okay, I is starting from 0 to n minus 2. N minus 2 means 3. We have to give I value for 0, 1, 2, 3. And for j it is 1, 2, 3, 4, that is n minus 1. And j equal to I plus 1, that is 0 plus 1, 1 to 4. I is 0 to 3. In the next condition, okay, for I equal to 0, first we take an I as a 0. Next we have to check what? Go to inner for loop. J is incremented by 1, that is j equal to 1. Now if a condition comes, if array of I equal to array of j. Okay, I equal to 0, j equal to 1. If array of I, a of 0 is equal to a of 1. Okay, in a of 0 we have 3 and a of 1 we have 2. Whether it is equal? No, false. Then it return 2. This condition is false, right? Return false. If this condition is true, then only it returns false. Here the condition is false, hence it return true. Okay, next again go I equal to 0, j is incremented by 1, that is j is 2. Next a of 0 equal to a of 2, a of I, a of j, a of 0, a of 2, that is a of 0 is 3, whether it is equal to 1, no, false, then return true. Again increment the j value, j becomes 3, now array of 0 is equal to array of 3, 3 equal to 3, yes, this condition is true, hence it returns false. Okay, next this array contains equal element. We need to check this 3 is equal to 2. No. Again we need to increment j value. Whether this 3 equal to 1? No. Again we need to increment j value, that is this value compare with this. Whether 3 is equal to 3? Yes. Hence this array consists equal element. Let's see another example which array have different element. Consider this consists 3 element. We have to give value for I 0 to 1 and j is 1 to 2, as I 0 to n minus 2, that is 1, and j is 1 to 2. In the initial condition, give I, first for loop is executed, that is I equal to 0 and j is 1, I plus 1. Next go if loop, a of 0 is a of 1. Whether a of 0 is 2, whether it is equal to 1? No, it is false. Next, whether this 2 is equal to 3? No, false. We have to check it I 0 and j 1 to 2. Next, we increment the value I by 1. Next, check again. J is, when we increment I equal to 1, then j becomes I plus 1. 1 plus 1 is 2. For I equal to 1, j equal to 2, array of 1 equal to array of 2. Okay, whether this one is equal to this 3? No, false. Hence we can say this array contain distinct element. Next, the mathematical analysis for this problem. The input size is number of element that we taken size of array. Basic operation is comparison, which comparison we did. Here we in the inner for loop we did comparisons, hence the basic operation is comparison. And best case, worst case and average case exist. Why? Because basic operation depend on n and check whether it is equal element in the array or not. In the worst case input is an array giving the largest comparison, that is array with no equal element, array with the last two element or one pair of equal element. We can only find the worst case which take the largest time, right? If in the array there is no equal element is find, then we have to keep check from the start in the array. We have to check if it is 2 5 3 1, then we have to start from 2 and 1, which is take longest time even though there is no element is same, right? Hence we check worst case efficiency array with no equal element, but we have to take the time for this checking, and array with the last two element are only pair of equal element. If this array consists 5 5 3 1 2, the last two element have the same equal values, then also we take longest time to reach here. This is the worst case efficiency we have to find. Okay, the fourth step, let C of n denote the number of comparison in worst case. Algorithm make one comparison for each repetition of innermost loop, that is for j between I plus 1 to n minus 1, and this repeated for outer loop for each between 0 to n minus 2. Okay, that is we taken for I equal to 0 to n minus 1 and j equal to I plus 1 n minus 1 innermost outer loop 1. The fifth step, simplify the summation using the standard formula. C of n is I0 to n minus 2 summation j I plus 1 n minus 1 1. Okay, we have to know the standard formula for this. Whenever the I comes, whenever this 1 comes, remember just upper minus upper bound minus lower limit plus 1, upper limit minus lower limit plus 1. Just remember the thing when 1 comes. Okay, in this formula, in this summation, upper limit is n minus 1 minus lower limit plus 1. Summation I0 to n minus 1. Here n minus 1 minus I plus 1 plus 1, plus into minus 1 plus 1 get cancels, n minus 1 minus I, and separate this ith term I0 to n minus 1 n minus 1 minus separate I0 to n minus 2. Whenever this I comes, remember this formula n into n plus 1 by 2, which is the standard formula. Okay, in this summation, in the place of 1 we have 0, and in the place of n we have n minus 2. Substitute n as n minus 2 into n minus 2 plus 1 by 2, that is n minus 2 into n minus 1 by 2. Okay, next taken the common out, n minus 1 summation I0 n minus 2 1 minus this. Again when the n1 comes, remember upper limit minus lower limit plus 1, that is n minus 1 n minus 1 minus this term. Next n minus 1, taken n minus 1 and n minus 1 outside. Remember remember thing is n minus 1, remaining term is n minus 1 minus n minus 2 by 2. Okay, n minus 1, solve this 2n minus 2 minus n plus 2 by 2, that is n minus 1 into n by 2, multiply n square minus n by 2. We have standard formula for n into n plus 1 by 2 is half n square. Consider as it is a half n square, and this C of n belongs to theta of higher order n, that is n square. Okay, this is the order of growth for this problem. The third non-recursive problem is matrix multiplication. Algorithm for matrix multiplication, we have two arrays 0 to n minus 1 and array of b of 0 to n minus 1 0 to n minus 1. Okay, 0 to n minus 1, and b matrix also consists 0 to n minus 1 elements. Okay, input is 2n into n matrix, that is A and B. Consider we have two matrix A and B. Let's see the algorithm. For I equal to 0 to n minus 1 do, for j equal to 0 to n minus 1 do. C of ij is 0 into 0. For k 0 to n minus 1, do C of ij, this is the formula, C of ij plus A of ik into B of kj, return C. Let's see this algorithm by this formula. First, for I equal to 0 to n minus 1 means 0 to, here n is 2 cross 2 multiplication matrix, hence n is 2. 2 minus 1 is 1. Again for j equal to 0 to 1, initial condition, this is 0 0 set as a 0. Okay, next k 0 to n minus 1, that k 0 to 1. Formula is C of ij. C of 0 0 is ij. C of again I is 0 0. A of ik. Again I is 0, k is 0 into B of kj. K is 0, j is 0. Okay, C of 0 0 is 0. We take an initial plus A of 0 0 is 3 and B of 0 0 is 2. Multiply, output is 6. In the next condition, again increment the k value by 1, k 1 to 1. Again for this formula, C of 0 0, C of ij is 0 0 plus A of ik. A is I is 0, k is incremented 1 into B of kj, k is 1, j is 0. That is A of 0 0 is 6 now. 6 plus 2 into 3, that is 12. We find the C 0 0 by 3 into 2 plus 3 into 2 plus 2 into 3, that is 6 plus 6, 12. We got C 0 0 as 12. Next again go for increment the k value, that is 2 to 1, that condition is failed, hence again go for loop, that is increment the j value 0 to 1, increment j value 1 to 1. C of ij, that is j is incremented by 1, that is 0. Again k 0 to 1, C of 0 1, again substitute the formula, and here j is 1, and I and k is 0, that is 15. Next again for this formula, increment k value 1, that is 1, and here 1 1, the output is 27. That is C of 0 1 by multiplying 3 into 5, that is 15, plus 2 into 7, that is nothing but 15 plus 14, 29. Next again k condition is filed. Again go for incrementing the j value. We already j 1 to 1 is already finished. Next again increment the I value. Like this way this loop is going to be executed for this algorithm and for this problem. Okay, next write the mathematical analysis. Input size is matrix of order n, and we consider in the second step we have to find the basic operation, that is we have multiplication and addition, but multiplication we perform in the every inner loop, hence addition is also we perform, but we consider multiplication as a basic operation. Next to know best case and worst case efficiency, since it depend only order of n input size. Let take m of n be the sum for total number of multiplication. One multiplication executed on each repetition of inner loop governed by variable ranging from 0 to n minus 1. Hence number of made for every pair of a specific variable I and j is k 0 to n minus 1 to 1. That we see in the algorithm. Total number of multiplication of m of n is expressed by triple sum. I0 to n minus 1, J0 to n minus 1, K0 to n minus 1, 1. Again, simplify the summation using the formula. Whenever 1 comes, write upper limit minus lower limit plus 1. Upper limit n minus 1 minus lower limit 0 plus 1. Remaining is n. Take this n out, J0 to n minus 1, 1. Again, when 1 comes, write upper limit minus lower limit plus 1. Again, remaining is n into n, that is n square. Take this out. For this summation, again I0 to n minus 1 to 1. Again, substitute upper limit minus lower limit plus 1, that is n. N into n square is n cube. Hence, this mathematical analysis say this m of n belongs to theta of n cube. That is the order of growth for this problem. Okay, if you understand this, then please don't forget to subscribe forget to like the videos, and please subscribe the channel.